Lesson 210, Solving Inequalities with Multiplying and Dividing, is separate for a good reason. Unlike the properties that we used before, properties of equality, this one doesn't have it. It is true that if we multiply or divide each side of an inequality by the same positive number, we will have a remaining true statement. So here's an example. 9 is greater than negative 12. If we multiply each side of the inequality by 10, we still have a true statement. 90 is greater than negative 120. And the same is said to be true of division. Negative 15 is less than or equal to negative 10. If we divide each side by a positive 5, we still have a true statement. Negative 3 is less than or equal to negative 2. So when we are multiplying or dividing with a positive number, we still have a true statement. But here's the catch. If we are multiplying or dividing by a negative number, then we will have a problem, unless we simply reverse the inequality sign. So let's take a good look at this. Here's our same statement as before. 9 is greater than negative 12. If we multiply both sides of the inequality with negative 10, however, we cannot keep the greater than sign or it won't be true, because the left side will simplify to negative 90 and the right side will simplify to positive 120. And negative 90 is not greater than 120, it's less than. So to keep this true, we had to reverse the inequality sign. So let's look at it with division. It is true, negative 15 is less than or equal to negative 10. If we divide by a negative number, dividing by a negative 5, we will have to reverse the statement for it to be true. The left side simplifies to positive 3. The right side simplifies to positive 2. And 3 is greater than or equal to 2. So when we are solving an inequality, we will undo addition or subtraction just like we always do. We will undo multiplication and division as usual, except if the number we're using in the inverse operation is a negative number, we must reverse the inequality sign. And because these are inequalities, we will usually need to graph our solution. So let's look at this example. There's a woodworker who is making a profit of $30 on each picture frame that is sold. How many picture frames must the woodworker sell to make a profit of at least $500? So the money that the guy makes from his frames, we want to be greater than $500 or equal to $500. F is going to represent the number of frames. So if it's $30 for each frame, we want that to be greater than or equal to 500. Now we have no negative numbers on this, so we don't have to worry in any way, shape, or form about switching an inequality sign. We are going to divide by 30. That's our inverse operation, is division. And here is where we get an answer of 16.6 repeating. Now, the question is, how many frames must he sell to make a profit of at least $500? Can he sell 16? Can he sell part of one? Can he sell 16.6? He must sell 17 frames to make a profit of at least $500. This is one of those problems you would need to round. Have a good time practicing.